All right, we're going to be talking about steam, and this is actually pretty exciting because we're finally to a topic we can really sink our teeth into. This here is where thermodynamics really starts, is right here. So I would encourage you to watch this video more than once if you have to. There's several practice questions in the exam bank that you need to, if you're going to need help on them. Look at the tutorials, and we're going to step you through each one of those questions to get an understanding of this. And if it's your first time, it can be kind of difficult. So if you come from the place where you worked for your Navy, from the Navy where you worked, you might have brain dumped it 20 years ago. So this will be a good way to catch up. So let's get to it. We're really going to be looking at our topic here. It's topic 3, and we're going to learn how to use this book, Steam Tables. We're going to get really good at it. We'll see everything that's in it. And also, we will learn how this thing works. I've mentioned it before, but this is a Mollier diagram. A Mollier diagram. So we'll take a look at that. And we will be looking at the steam tables and very many knowledge requirements. 23 knowledge requirements in this. All right, so I'm sitting here starting out. Introduction, thermodynamics of steam. So the first thing we need to know is we're going to be talking about our working fluid, and what happens is it undergoes several different processes. So this is steam. And in the upper left-hand paragraph, one of the reasons we use water, which then turns into steam if we heat it, obviously, is water. If you're looking right here, why would we use water as our working fluid? Well, it's abundant, and it has a high specific heat capacity, and a new term, a high critical temperature. So steam is often used as a working fluid when it comes to generating electricity. As discussed earlier, we could have intensive or extensive properties, just a review of those. Intensive or extensive properties. If a property is independent of mass, we said it's intensive. It's independent of mass. And so that's just a little review. And the other one was specific properties. A specific property is a property that is specific to 1 pound mass. So if I know that I'm dealing with 1 pound mass and I take the volume per 1 pound mass, I have specific volume. If I was to look at the enthalpy that's contained in 1 pound mass, I have specific enthalpy. Small letters denote specific properties. If I want to know the entropy that existed, that would be a little s. Little s. Those are going to be 3 important properties that we look at. So under section 1.1, we're going to start right off with steam production. And we get a really cool drawing. And, oh, I missed, where's my, hold on, I got to pause. I got to go get something to wipe the board off with. I don't think this will work that good. Oh, it's pretty clean. It'll work. Okay. So down here, we get a cool drawing right there. And look at the shape. Here's water that's being heated, and then it comes up, and then we're going to have this plateau, and then we're going to go like this. The shape of that line is so important. The shape of the line is unbelievably important. So we're going to take a pot of water, 1 pound mass of water, and here's a pound mass sitting in here. And we're going to measure the temperature of that water as we supply heat, and there is 1 pound mass of water there. And if we were to plot the temperature, assuming atmospheric pressure, this is the atmosphere out here, 14.7 psia, and I plot the temperature. And I would see it go up and up and up, and I would reach a point at which it no longer rises. And we know that that occurs at 212 degrees. And at this point in time, my pan would still be full of water. But the water is now saturated with energy. And it has increased its specific volume a little bit. But now if I continue to add energy here, from the point at which it became a saturated liquid, and I plot it, I know that I no longer see a temperature increase. What I do is I see this occur. Temperature doesn't change. Until I get to this point right here, which is still 212 degrees. Oops, messed that up. And we call this point a saturated vapor. And we'll be going over this over and over and over again. And at this point in time, there is no water in the pot. It has all been evaporated to steam. And if I add energy now to that saturated vapor, I can get above 212 degrees up here. And look at the shape of that curve. It goes up, across, and up with some very key points right here and here. This is at a constant pressure. Temperature rises, then temperature remains the same, and then temperature rises again. This right here is where evaporation is occurring. Evaporation is occurring between these 2 points at a constant temperature. We said this point will be considered the F point, and this the G point, and the distance between them was known as FG. Very key. So on the right-hand side of your learning material, relative to that drawing, it says assume at atmospheric pressure you have an initial temperature of 60 degrees. So I just put 60-degree water in here, and I just turn this burner on. As I start to raise the temperature up, on the second paragraph, you'll see the addition of heat actually raises the temperature. Now we call that a sensible heat addition. When you see temperature actually rise from, say, right here, 60 degrees to 212, when you see temperature rise, that's a sensible heat addition. And a thermometer is placed in the pan, like as you see right here, and we'll see that temperature rise at atmospheric pressure till it gets to that point right there, which becomes a saturated liquid. We got to look for that phrase too when we're looking at questions. F point, that's its enthalpy at that point. So the temperature will no longer increase. Any addition of heat at that point in time from here on over is going to result in steam production, a phase change occurring at a constant temperature. So the water is said to be saturated with energy, and we call it a saturated liquid, and any addition of energy to a saturated liquid results in steam production, evaporation of the steam.